Okay, good morning, everybody. My name is Phuc. I am professor of the University of Information Technology, Vietnam National University. Today I will start chapter 1 of the course about the database theory. In this chapter, the chapter 1 objective are I will describe the characteristic of business database and the feature of database management system. I will appreciate the advances in database technology and the contribution of database technology to modern society. I will help you to understand the impact of database management system architecture on distributed processing and software maintenance. And I hope you pursue career opportunity related to database application development and database administration. Welcome to chapter 1 on introduction to database management. Database management is crucial to the operation and management of modern organizations. You know now, on company, they have database, they have information system. Database is an infrastructure for daily business operation. And raw material for long run is very important for decision making. Now you see, the transformation. As significant as learning computer programming and algebra, we need the computing skill. About the time, assignment and project, lots of practical skill. And in this subject, you will be familiar with a very good textbooks that we use to study the database. And database field, many employment opportunity with good pay, high salary, and of course challenging work, sometimes too challenging. In this course, you can study a good book. This is the first course in database management. This good book was designed for students without a previous course in database management. Beneficial even for those with significant database experience. This is truly a good book. In the first part of textbook, there is an overview of database management and overview of database development. In the second part is the fundamental of relational databases, relational data model, sequence, basic query formulation skill. In the third part of textbook, we will study about the data modeling and conversion, developing a database skill used by database specialists or functional user developing a database. About third part of textbook is about the data modeling and conversion. We will study how to develop a database. We will show you the skill used by database specialists or functional user developing a database. About the fourth part is about relational database design involving normalization and physical database design, and so forth. I hope you will enjoy the textbook. Now let me go to the outline of this chapter. The first one I will discuss with you about the database characteristic. The second one is a DBMS feature. You can find this feature. You can find this feature in most DBMS. Desktop and enterprise. Then I will discuss with you about architecture. About the background for application development and distributed processing with database. And about the organizational roles, how you might be using a DBMS in your work. Now let me go to initial vocabulary. In this slide, I will discuss with you about the data, about the information, essential to organize data. The first one is the data. Data, you see, most organizations have a flood of data. Too much data is a problem. And raw facts about things and events. For example, you see, you have a database of names of the customer, date of birth, or about the salary of your employee, about the interest rate, about the cost, and major a lot of data. And maybe now you have the data form like imaging, like engineering drawings, like maps, like video, like fingerprint, like text series, and so forth. We have a lot, many kinds of data now. And we must convert the data from data to information. And data is a very, it's very important, because you see, from the data you can transform data that has value for decision making. Now let me go to the database characteristic. You see, there are three characteristics. The first one is persistent. The second one is interrelated, and the last one is shared. Persistent means last a long time, not transient. Last longer than the execution of a computer program. Interrelated means entity cluster data about a topic, customer, student, loan, and they will link together. Later you will study in the database there are many tables. And when we want to convert from data to information, you must link them together. And share, what does it mean? Share is mean this information, this data can be shared, you can share the information in the database. It means share means you have a multi-user. It means many users, many people simultaneously use a database. For example, you see you have a database in the university. The student can go to the database in order to know about the learning result. It means they can share the data in the database. Now, let me go to an example about the database. The first one is a university database. In the university database, you see you have many entities, like student, like faculty, like courses, like offering, like enrollment. And between the entity, you have relationship. For example, you see the relationship between faculty and offering. This relationship means faculty teach offerings. Or between students and offering, you have a relation enroll. It means student enroll in offering. And from relationship, you can answer the question such as what offerings are available for a course in a given academic period, or who is the instructor for an offering of a course, or what students are enrolled in an offering of a course. Now I go to the second example database. Got the utility database. And you know, in this database, you have entity such as customers, meters, bill, payment, meter readings. And you also have many relationships. For example, between bills and the customer, you have relationship bills sent to customer. Or between customer and payment, you have relationship, customer, make payment, and so forth. And you see out of cylinder, you have a billing, you have payment processing, you have a service stop, you have meter reading. Later you will know they are the operation of a database. Now let me go to database management system we call DBMS. DBMS collection of components is a modern software. The first one is Enterprise DBMS. Enterprise DBMS means a very, big DBMS. This kind of DBMS can support mission critical information system. It's a very large database system. There's many user, high performance requirement in a very big company. Desktop DBMS is end user department and small database only. And embedded DBMS means the embedded DBMS resides in a larger system, either an application or a device such as a personal digital assistant or smart card. Embedded DBMS provide limited transaction processing feature, but have a low memory processing and storage requirements. Feature common to the most DBMS, database definition, non-procedural access, application development, procedural language interface, transaction processing. Now let me go to about the database definition. Database definition, the first one is how to define a database. The first one, you must define a database structure before using a database. When you define a database, you must supply the structures. And remember, in the database, we have a table and relationship. And we have a sequence statement like create table that you can use to create a database. And you also have a graphical tool later you will study in order to help you to create a database. Now this is a university database. And you see here, this database was created in asset. You see asset relationship window here. And in this window, you have 5 tables. Student, enrollment, course, offering, faculty. Remember, faculty 1 is not a real table. I will discuss later. Relationship is a line connecting tables. Faculty to offering. Not all tables are directly connected. Must define the table and relationship before you entering data and retrieving data. Now this is a university database. I discussed with you about the ERD. ERD stands for Entity Relationship Diagram. Later in this course, you will study about the Entity Relationship Diagram. The first one, entity, means similar to a table. A relationship means the connection between or among entities. Now let me go to non-procedural access. Specify what, not how. Inquiry, request for data to answer a question. Indicate what parts of database to retrieve, not the procedural details. And of course, non-procedural access, improve productivity and improve accessibility. And we have a sequence select statement and graphical tool that can help you to do a non-procedural. procedural access. Now I go to the graphical tools for non-procedural access. You see in access, you have a graphical tool like we see in the slide. And here you see you have two tables. I mean, the first table is name enrollment, and the second table name student. And in the lower part of the screen is the graphical tool. And you can move the fields from enrollment or student into this table. For example, here you see you want to set up a query. The first field, student first name, you take from student. Student last name, you take from student also. Student city, you take from the table student. But offering number, you take from table enrollment. Enrollment rate, you take from enrollment. It means you make a join between two tables in order to have the answer of the query. Now I go to application development. You see a form formatting document for data entry and display. And you see non-procedural access by Excel. It is not useful because of default output appearance. Non-procedural access combined with graphical tool for form and report development is very powerful. And here you see non-procedural access make form and report creation possible without intensive coding. You don't need to code anything right out of the code, but you use a non-procedural access to make a form. And when you use non-procedural access to specify data requirement of form or report. Now I go to a sample data entry form. The form here you see you have many text field like social serial number text field, like first name, like last name, department, and you have a table here assignment. This form can be used to add new course assignment for a professor and to change existing assignment. This one. I go to a sample report about faculty workload report for the academic year 2005 to 2006. And the report used indentation to show courses taught by faculty in various departments. The indentation style can be easier to view than the tabular style shown as default output style. Now I go to procedural language interface. You see here we can combine external languages like COBOL, Java, C, C++ with SQL. And we have a new DBMS specific language like PL, SQL, Oracle, and transaction SQL Server. We have back processing. Why? We have back processing. Most business processing is a batch. Collect a long application and process together. Online processing is becoming more prevalent because of the web. And about customization and automation. Customization means customize the behavior of a data entry form. And automation rule processing. Check when an order is placed. And the performance improvement, I think we more control with the procedural language. Now I go to transaction processing. Transaction line, you have an ATM. You go to an ATM to withdraw the money, or maybe you have transaction when you go to a supermarket. Transaction means a unit of work that should be reliably processed. And major difference between enterprise and desktop DBMS. Transaction process ability. A major cost difference. And about the transaction, you can control simultaneously user or recover from failure. Now I go to the database technology evolution. Error. The first generation. Symbolic sequential and random searching. But the user will require to write a computer program to obtain access. I go to the second generation. From in the years 1970. The second generation products were the virtual DBMS, as they could manage multiple entity types and relationships. However, to obtain access to data, a computer program still had to be written. A second generation system are referred to as navigational because the programmer had to write code to navigate among a network or link record. I go to third generation from the years 1980. Third generation systems are known as relational DBMS because of the foundation based on mathematical relation and associated operators. Optimization technology was developed so that access using non-procedural language would be efficient. And about fourth generation system can store and manipulate unconventional data type such as imaging, video, maps, sound, and animation. Because this system view any kind of data as an object to manage fourth generation system and some type called object-oriented or object relation. I discussed with you about the DBMS Marketplace. We have enterprise DBMS and desktop DBMS. In enterprise DBMS, I discussed about the Oracle, about the SQL Server, about the DB2, about significant open source DBMS like MySQL, Firebird, PostgreSQL, about the desktop DBMS like Asset Dominance, for Pro Paradox, Approach, FileMaker Pro. And according to the International Data Corporation (IDC), the sale, license, and maintenance of enterprise database software reached to the 13 billion in the year 2003, and increased estimated 10% per year. So the enterprise database software value is very, very large. Database independence. Database independence is a database should have an identity separate from the application. For computer programs, forms, and reports that use it. The separate identity allows the database definition to be changed without affecting selected application. And you see here software maintenance is a large part, 50% of information system budget. And about the data independence, you can reduce impact of change by separating database description from application. When you change the database definition with minimal effect on application that use the database. Now I go to 3 schema architecture. Schema, what does it mean? Schema is a database description, and reference attributes for compartmentalization, database decryption. You see here that there are three levels. Conception level, the base table. External level is external views. And internal level, it means implementation details for the base table. Indexing. This is then clustering. And in the chapter 10 of this course, we will discuss about the physical database. Now, I go to differentiate among level to make the three schema level clearer. In the book, table 4 of the book, show the differences among database definition at the three schema level using example from the feature described in section 1.2, even in a simplified university database. The difference among the schema level is clear. With a more complex database, the difference would be even more pronounced with many more views, a much larger conceptual schema, and a more complex internal schema. And the schema mappings describe how a schema at a high level is derived from a schema at a low level. Now I go to the client-server architecture. Client-server architecture is an arrangement of components, client and server, and data among computers connecting by a network. The client-server architecture supports efficient processing of messaging requests for service between clients and server. And to improve performance and availability of data, the client-server architecture supports many ways to distribute software and data in a computer network. The simplest scheme is just to place both software and data on the same computers. Now I go to organizational roles because databases are pervasive. There are a variety of ways in which you may interact with database. The classification in this figure distinguishes between functional users who interact with database as part of their work and information system professionals who participate in designing and implementing database. Each block is a hierarchy represents a role that you may play. You may simultaneously play more than one role. For example, a functional user in a job such as financial analysis may play on 3 roles in different databases. In some organizations, the distinction between functional users and information system professional is blurred. In the organization, functional users may participate in designing and using the database, and functional user can play a passive or an active role when interacting with database. About the database specialist, about DBA, database administrator, is focused on individual database and DBMS. Any strong skill in specific DBMS. About the data administrator, planning. They must know how to plan. About the database and technology. Standard setting in computerized and non-computerized databases. About a large organization have a separate position. Small combine 2 roles together, and both positions require more than at least 1 database course. Summary. I want to summarize all the things I discussed with you in this chapter. The first one is the database and database technology vital to modern organization. And database technology support daily operation and decision making. Non-procedural asset is a crucial feature and many opportunities to work with databases. Thank you for your learning. Thank you.